All right, we're going to talk about density today. All right, so here are our objectives. Pause the video, peruse it, read it carefully if you want. So let's talk about density. Well, density is a physical property. Okay, you don't need to have a chemical change happening. And it is, by definition, the ratio of mass to volume. So density really is how compact the mass is, because it's measured as mass per unit of volume. So it's how tightly packed the particles are. So if something has a high density, those particles are really crammed close together. If something has a low density, those particles have more space between them. The formula for density, where do you find it? You find it on table T. And it tells you the formula, and it tells you what everything in the formula stands for, so you don't have to wonder, okay? Now, to figure out how to calculate mass or how to calculate volume from that formula, you can use this triangle. A lot of people prefer this method, so you're writing it just like the formula is density is mass over volume, so you write it like density, mass over volume, okay? So you can write it as this triangle, okay? Now, why would you want to do that? Well, we can use this triangle if you know what it looks like, and if we cover this, so use our hand and we cover the D because we're solving for density, then what we're left with is M over V, so density is mass over volume. But what if instead of doing that, we want to find volume? So this time we cover the V and we're left with volume is mass over density. You can do the same thing by just rearranging the formula, but for some people the triangle helps. So then if we want mass, we cover mass, that's at the top. You have the D and the V next to each other, so it's density times volume. So let's try an example problem. The volume of a sample of aluminum is 13.4 milliliters. Calculate the mass. So I'm finding mass, right? So if I cover that up on the triangle, I know it is density times volume. I have to look up the density of aluminum on table S. So there's what it is. And I set up the formula. Mass equals density times volume. So I set up, that was the density from table S. That was the volume. And then I plug the numbers in the calculator. Remember, those milliliters are going to cross out because when this is on the top, this is on the bottom. And we're left with 36.18 grams. Now, significant figures, which we haven't talked about yet, but we need 3, which means I have to round my answer. Okay. All right, here's another example. The mass of a sample of lead is 55.37 grams. Calculate the volume. So we're finding volume. So that means the formula is mass over density. You look up the density of lead on table S, and it is 11.3 grams per centimeter cubed. So I'm going to set it up. The mass was 55.37. The density was 11.3. Now, grams per milliliter means like grams on the top, milliliters on the bottom. So I'm going to flip it. So I'm going to leave the grams here, but milliliters would really be on the top. It means on the other side. Okay, so the milliliters comes up here, which means in the calculations I can cross out grams, and then I'm left with the volume in milliliters. Again, significant figures, which we'll talk about in a lesson soon, but the volume I'm going to express like that. Now, what does a density graph look like? Looks like this, okay? It's a linear relationship, okay? Floating versus sinking, that relates to density. An object will float if it's less dense. An object will sink if it is more dense. Also, two liquids can simply float or sink on top of each other. You know, if you put oil on top of water, the oil will float on the top. So you can make a density column. The substances will float in layers based on their density. The lower density liquids will float on the top, and the heavier, the bigger density liquids will be on the bottom. For density, because it is a physical property, you can actually use the density to identify an unknown substance. So you can measure the mass using a balance. You can measure the volume by seeing how much volume it displaces, as a lot of times you'll be given something that has an irregular shape. then you can calculate the density. And so for elements, we can use the density values on table S to figure out what actually the sample was made of. So here's an example problem. So the mass of a metal is 165.2 grams. The volume is determined to be 21.0 milliliters. What is it made of? So I'm finding density, mass over volume, put the numbers in, do the calculation. This does have 3 significant figures, which is what I need. Now look for 7.87 grams per milliliter on table S. And what is it? It's iron. Fe is the symbol. All right, so this table and graph shows a relationship of direct proportionality, a linear relationship between mass and volume. Okay, so based on this information, what is the relationship? Are they unrelated, no relationship, linear, inverse, or exponential? You should know it's a linear relationship. And in class, we could practice with the blue kit. And there you have it. There's a little bit about density, and hopefully you learned something new.